In the last video, we had a general overview about asynchronous JavaScript. In this video, we're going to see one of the ways to achieve asynchronous programming in JavaScript with the use of asynchronous callbacks. So let's get into it. Because we know that in JavaScript functions are often called first-class functions, as they are treated as any other variables and can be passed as arguments in other functions. So simply put, asynchronous callbacks are functions that are specified as arguments in other functions that generally do some asynchronous I/O operations such as fetching data from a server or writing in a file or any other operations that are not part of the JavaScript core functionalities. Basically, asynchronous callbacks wait for something in the background to happen before they get called back. And this is the reason for why they are called callbacks after all. One example of asynchronous programming in JavaScript to give would be the use of add-event-listener, which is part of the web API in the browser. In this example, a callback function has been specified as a second argument to be called whenever the event is fired. So when the button gets clicked, the callback function is going to be called, and therefore the message clicked will be printed. One question that might be asked is, why do we need to use asynchronous callbacks in first place? The answer is, as being part of the asynchronous programming paradigm in JavaScript, they are useful to control the order in which the code is run. To better understand that, let's have a look at an example. Let's say that we want to fetch some data asynchronously from an external source, and then we want to do something with the fetched data. Let's jump into the console and try to solve this problem. In this first solution, we are not using the asynchronous approach. We are defining two functions. One of them simulates fetching data from an external source, and the other simply simulates that we are doing something with the data. If we invoke the two functions fetch data and do something with data in this order, and then hit enter, notice that we are not getting the expected output. We're getting doing something with data printed before fetching data, which is quite understandable, and this is because of the synchronous nature of JavaScript. Now if we tweak this example a little bit and pass a callback function's reference to the function that fetches data, and invoke the function fetch data with do something with data as an argument, what ends up happening is that now we are sure that the callback is going to be run just after the data is fetched. If we hit enter, we see that fetching data is printed first, then doing something with the data second, and that's the order we are looking after. Even though asynchronous callbacks are awesome, there is one pitfall I want to talk about before ending this video. Let's assume that besides fetching data asynchronously and doing something with the data, we want to send the data back to the server and notify someone that the data has been sent back. Let's jump into the console and see how this problem can be solved with asynchronous callbacks. You see that to meet our goal, we end up having a nested structure of asynchronous calls. If we hit enter to run the code, we will get the expected output, but notice that the complexity of being able to read the code rises significantly. Imagine that we have to control the order of hundreds of asynchronous calls. This would be impossible to read. This phenomenon is often called the callback hell, and that's something that I want you to be aware of when using this style of asynchronous programming. So to provide a much clearer syntax while doing asynchronous programming with JavaScript, ES6 has introduced what we call promises. In the next video, we'll have a look at them and how they work. Thanks for watching and see you soon.